Hi friends, this video we are going to find the Fourier transform of the function f of x equal to exponential of minus ax times h of x minus exponential of ax times h of minus x. Here a is some positive number. So the given function is, I can write it as, first Fourier transform f of x formula is minus infinity to plus infinite f of x exponential of minus I omega x times dx. So from this one, this is Heaviside function. What is the definition of Heaviside function? H of x equal to 1 whenever x is positive, 0 whenever x is negative. What is the meaning of h of minus x? So this is little ulta. 1 whenever minus x is less than 0, so minus x is greater than 0, and 0 whenever minus x is less than 0. This implies these guys become x is negative and this guys become x is positive. Okay. So then our integral become integral over minus infinity to 0, the function value is exponential of ax times exponential of minus I omega x dx minus time, because only in whenever x is negative this guys become 0, only this guy is only valid, that is why I write here. Second one is plus integral over 0 to infinite. Whenever x is positive, this guys become 0, only this guys only will remain there. So exponential of minus ax times exponential of minus I omega x dx. Now I will take this one is my I1, this one is I2. I will take as, then I1 equal to minus time integral over minus infinity to 0 exponential of a minus I omega times x dx. If you are integrated, what will you get it as? Exponential of a minus I omega x divided by minus time a minus I omega. Now minus infinity to 0. Now the lower limit I have no, upper limit I don't have any issue, but lower limit is I have to little tricky here. Correct? Limit extends to minus infinite exponential of ax is 0 whenever a is a positive quantity, but limit extends to infinite exponential of minus I omega x is not defined, it's undefined, correct? But I know that this is lies, it's a bounded number, that is I get the clarity. Because of this is, I can write it as limit extends to infinite cos omega x minus I sin omega x. So these two guys are, whenever extends to infinite, this guy is bounded by minus 1 to plus 1, this is also minus 1 to plus 1, it's a bounded number. So this guy is multiplied by 0, this become 0 only. So that is why these guys become 0 for the lower limit. What about the upper limit? Upper limit I have no the issue. So minus 1 over a minus I omega. What about the lower limit? Lower limit is minus time minus is become plus. This guys become 0 because of this scenario. Now we go for the I2. I2 is integral over 0 to infinite exponential of minus a plus I omega times x times dx. This is our I2. Now if you are integrated, you will get it as 1 minus 1 over a plus I omega times exponential of minus a plus I omega times x 0 to infinite. At the lower limit I don't have any issue, but upper limit infinity, the same argument what I applied for the I1 case. So then this guys become 0 plus, because lower limit is 1 minus will come, already 1 minus is there, so it's become 1 over a plus I omega. So my f of omega is I1 plus I2. So f of omega equal to I1 plus I2. So this is nothing but minus 1 over a minus I omega plus 1 over a plus I omega. If you are taking, you will get it as a square plus omega square minus time a plus I omega plus a minus I omega. So this multiply, this a will automatically will cancel, that minus I omega plus I omega. So minus 2I omega divided by a square plus omega square. This is our f of omega. Now if you limit a tends to a is a positive quantity, what will happen? A is equal to approaches to the 0. Whenever a is approaches 0, these guys become sigma function, that is sine function. Okay, say 0, this function become 1 whenever x is positive, minus 1 whenever x is negative. So what is the Fourier transform is? Fourier transform is a is tends to 0, these guys become minus I omega divided by omega square, this omega will cancel, so 2 will be there, 2 minus, so this become minus 2I divided by omega, or you can write the I is, you can write as 2 over I omega, because this minus I equal to 1 over I, so that's why you can write it. This is the Fourier transform of sigma function. I hope you understand how to calculate the Fourier transform of any given function. Thank you for watching this video.